To begin our functional programming journey, we need to learn the differences between immutable and mutable data and understand what they both mean and why we should choose one or the other. Now, in this video, I want to take some time and start off beginning with talking about the differences between let and const and this theory of immutability built into JavaScript. We're then going to look at a few misconceptions, talk about object.freeze, and then explore a few methods that we can adopt an immutable approach to updating our data structures, and this means things such as objects and arrays. And by doing so, we'll also explore the downsides of immutable data. Now, I think one question tends to be immutable. What is immutable? Now, immutable simply means that something cannot be modified after it is created. That's all it means. You can almost think of it as an envelope. You know, when you've put a stamp on something and you've sent it off in the mail, that letter cannot be changed. It's gone. So understanding this immutability is a core concept of functional programming that's going to promote predictable state changes for us, and it's also going to make those irritating, hard to find bugs go away. Now, before we go into let versus const, etc., I want to discuss how JavaScript strings, for example, already have built-in immutability. So let's first create a constant of a, and here I'm just going to give it a string name. Now, if we go ahead and say console log a, we can save this out. Now, in the browser, I can open up my console as well, and you can see that we have our log. So this is nice, and it's kind of what we'd expect. Now, I'm deliberately using a let statement here because we're going to reassign a. So let's say that we're going to instead assign the value of a drink. We're going to then hit save. Now, this isn't immutability. This is reassigning a value. We have one string here and we have one string here. So JavaScript is not doing anything fancy here. We're simply reassigning the value of a string to a brand new string. But it also gets confusing when we start to look at the keywords such as const. And how does a const variable differ from a let variable? Now, using const simply means that we cannot reassign something. So in fact, if we're not going to change the string, I tend to favor using a constant. So for example, we could say a, which is our let on line 3, and we could use something like slice. You can see here that we have the index to the beginning of this specified portion of the string object. So what we in fact need to do is pass in the number of the start and the end of where we want to slice the particular string. So if we then compare A and B inside of our console log, we then just get the first letter because we're saying, give me everything from 0 to 1. So that's exactly what slice is doing. So this whole concept of immutability now comes back round. JavaScript has built-in immutability with these strings. Here I've just demonstrated reassigning. That is not immutability. But immutability here is the fact that when we call our slice method on our string value of a, under the hood, JavaScript is spinning up a new string and it does not ever mutate the original string. And how do we know that? Because we're also logging console log a, which, as you can see, has been printed out fine. So that's actual immutability built in. We're calling a method. It looks like it may be similar to things such as array slice and splice and push and these other methods that live on other objects in our JavaScript. So that's a very brief introduction to immutability in what's already built in for us with JavaScript. However, I want to take this a little bit further. Let's create a new object. Now here we're going to give it an ID. You can give this an ID of anything you like. I'm going to use some fries. We can then give it a name property. And finally, a price property, and we'll set these as 199. So because I'm using a constant here to hold the value of our object, it means that we cannot reassign it. If we were to do x equals 1, 2, 3, 4, we can attempt to see what this would do in the console, but immediately we're getting some ESLint warnings, and we also see them printed out in the console too. Now the error is explicitly x is a constant and we cannot reassign it, which is completely valid. Now, simply using const, however, does not guarantee that things will be immutable. We can demonstrate this by saying x.id and then simply reassign a different character. So we can then hit save, and you can see that when we log out our x in the console, we then have a completely different ID. Now this is actually mutating our constant. Remember, all that using a const doesn't allow us to reassign. However, if something is an object, we can reassign it. And this also goes for things such as nested objects, if there was going to be another object inside of this object. Now this gets really interesting because how do we make this immutable? This is all we have in JavaScript. So there's something introduced a few years back called object.freeze, and you may have already seen this. What we can simply do is wrap our object inside, and when we hit save, in the console, assign to read-only property ID of object. So now we're actually seeing some errors that we're trying to assign a value to an object which is considered frozen, which means that it's read-only. If we comment this out, we then fix the problem. So what this enables us is to have 100% read-only, a frozen object, and we can do this for arrays as well. So throughout this course, we're going to be dealing with purely immutable data structures in this functional programming chapter. Now in this video, we've talked about the differences between let and const. Let we can easily reassign. Const stays constant and we cannot reassign it, as we've demonstrated down here. But we've also learned that simply using const does not guarantee immutability, which is why we've introduced an object.freeze. We then demonstrated our error by reassigning or attempting to reassign an ID property on our object. Now there's one thing to also note, the object.freeze is not going to freeze any nested objects, so it only works on this top level object. So that's it for this video. I want to cut it there. In the next video, what we're going to jump into is exploring some immutable update patterns in JavaScript for dealing with objects and dealing with arrays, which is more important for us when dealing with functional programming, so we can promote those predictable state changes and lessen those hard to find bugs. We're also going to be talking about immutable data structures and how they enable us to have a nice performance enhancement through something called an identity comparison. So that's it, and I'll see you in the next video.